All right, in this lesson we're going to cover circles, in particular circumferences, areas, arc length, sectors, and segments. All right, let's take a look at circumference here. As you might know, the distance around a circle is called a circumference. It's basically the perimeter of a circle. What is the measurement around the circle? And I'm going to show you a few ways to find that depending on the information you know. So let's say you know the radius of a circle is 5. Then the way you calculate circumference would equal 2 times pi times the radius. So in this case that would be 2 times pi times 5. If you multiply 2 times pi times 5, you would get 31.42. But let's say you knew the diameter. That would make this look a little bit different. Let me reverse a little bit here and show you how to calculate if you know diameter. So if you knew this was 5, then you know the diameter is 10. And it's a little bit easier. If you know the diameter, all you do is pi times diameter. Again, that's pi times diameter. Pi times 10, 31.42. Same answer, makes sense. Just different ways of finding the same answer, depending on what you know. The last one's actually a little bit more confusing. Let's say you didn't know anything about the radius or the diameter, but in fact, let's say you knew the, erase some of my circle over here, fill it in with some blue. Let's say you knew the area. Let's say you knew the area of this circle was 78.54. Now that's a weird number, but trust me, it makes sense. So let's say you knew that, again, the area is how many squares fit inside the circle. Let's say the area is 78.54. The formula would be circumference equals, I'm going to do that again, the square root of 4 times pi times the area. In this case, that is 4 times pi times 78.54. You were to type that into a calculator and do the square root of that, you would get 31.42, the same number we've been getting. So that means that the distance around this circle is 31.42. All right, now let's talk about the area of a circle. Just a reminder, area talks about the inside of something. Inside of a flat object is going to be the area. Basically, how many squares fit inside of this circle. So, just like before, there's a few different formulas we use to calculate area, depending on what you know. So again, let's say my radius is 5. To calculate the area, if I know the radius, area equals pi times radius squared. In this case, that would be pi times 5 squared. 5 times itself is 25. Therefore, the area, pi times 25, is 78.54. Again, the number from before, 78.54, is how many squares there are in this circle. I'm going to erase some of this. We can start over with a new figure. Let's say I know the diameter. And yeah, if you know the diameter, you know the radius as well, but let's say that's what I got. So that diameter would be 10 here. The formula is a little bit different. Pi times diameter squared over 4. In our case, that would be pi multiplied by 10 squared over 4. That would be pi times 100 over 4, which of course equals 78.54. This is what you want to pay attention to. The formula on how to solve it. Pi times diameter squared over 4. That's if you know the diameter. Again, I'm going to erase this bit. And let's say you didn't know radius or diameter. Well, let's say you knew the circumference was 31.42. To solve the area when you know the circumference, circumference squared over 4 times pi. My circumference is 31.42 squared over 4 times pi. 31.42 squared, kind of a big number, 987.22. Now 4 times pi, not something we can easily do in our heads typically. It's 12.57, sorry, I wrote the wrong number. 987.22 divided by 12.57 is 78.54. And it makes sense that I'm getting the same numbers over and over again because I'm just finding the same answer using different methods. Again, this is what you want to look at. How do you find the area when all you know is the circumference? Circumference squared over 4 times pi. All right, now on to something maybe totally new for you. We're going to be looking at how to find arc length. This, whoa, that's bad. This is an arc. It's even worse. It's basically kind of following the edge of a circle here. That's an arc. So we're going to find how, like, the distance between here and here, or how to do that. I'm actually going to use a different portion of the circle though. So a few things. Let's say I had my points here, A and B. And I need to know the distance between A and B on the circle itself, the arc length. The way I would write that would be the length, it's a cursive L, the arc length of AB. And over AB goes a kind of a curved line, not a straight line. And let's say it was 10. This is the way I would write my answer. The length of arc AB would be 10. Again, this is just how you write the answer after you find it. I'm going to backtrack a little bit here and teach you how to find that. Before you can find it though, there's a couple things you need to know. You need to know the central angle. And you also need to know the radius. So here I'll give us a central angle. Central angle is the measurement of basically from point to point going to the center of the circle. It creates its own angle. And let's say this was 86 degrees. And then my radius here would be 10. So again, I need to know my central angle. I need to know my radius. I'm going to erase this here and show you how to find the arc length when you have this information. Again, I'm looking for this length right here. Yeesh. Yeah, much better. Looking for that line right there, that arc. The formula. Arc length is 2 times pi times r times circumference over 360. Kind of weird. Arc length, which we can just write AL if you want to, is 2 times pi times r multiplied by circumference divided by 360. I'm sorry, central angle divided by 360. I kept on calling the circumference. This is 2 times pi times r times central angle over 360. So I'll work it out for you right now. Let me erase this though. Again, I'm just going to use AL instead of arc length. It is 2 times pi, my radius is 10, times the central angle divided by 360. 2 times pi times 10, multiply by the central angle over 360. And now this is just algebra. You would solve the parentheses first, then multiply, then find this product, then multiply it together, and you would get 15. It means the length here is 15. So again, you would write the length of arc AB is 15. The length of arc AB is 15. That's how you find arc length, right here. All right, so last one here. As you can see, I've already kind of done some markings here. This is the area of a sector. And yeah, last one, I decided to not go over segments in this video. It was gonna be too long, so we're gonna skip segments, just gonna talk about area of a sector. So this is a sector over here. It's basically the area within a central angle. It's like a piece of pizza, basically. So how big is this big slice of pizza here? So I'm looking for this area. How many squares fit in this area right here? I'm gonna have to erase that bit and then redraw my lines. Looking for this area right here. This formula, the area of a sector is pi times radius squared multiplied by central angle over 360. And as you see, just like before, I need to know some things. I need to know that my central angle is, again, 86 degrees. And let's say my radius is 4 this time, 4 feet, 4 inches, whatever. My central angle is 86, and my radius is 4. If that were the case, this would be pi times 4 squared multiplied by 86 divided by 360. Pi times 16, which is 4 squared, is 50.27. 86 over 360 is 0.24. Now, 50.27 times 0.24 is 12. Maybe 12 and some change, but depending on how you rounded your decimals here, we're looking for 12, 12.0605, whatever. The answer is 12. That means the area here, there are 12 squares over here. 12 units squared. So the way you find the area, pi times radius squared times central angle over 360. That's how you find the area of a sector.